3, 2, 1, and liftoff of Space Shuttle.
Since April the 12th, 1981, the Space Shuttle has been NASA's main space vehicle, and keeping it running is essential to the completion of the International Space Station. But in 2010, the shuttle is due to be retired, to be replaced by a new generation of Ares rockets designed to take mankind back to the moon. But just like the shuttle, Ares will rely on the solid rocket booster. With almost 500 tons of fuel and as tall as the Statue of Liberty, keeping these massive boosters flying demands a rigorous process of regular testing. So, how do they do it? Utah, USA. Cowboy country. These vast open plains attract those who are looking for peace and tranquility. And most of the time, they get it. But these wide open spaces also attract those who want to build and test enormous rockets. And here in the heart of the desert is the home of the ATK rocket facility. It's 7 a.m. on a hot June morning, and the team are getting ready for one of the highlights of their calendar. Because today they get to set off the biggest firework in the world, as engineering manager Gary Bates explains.
This is a solid rocket motor that we produce for NASA. It's used in the launch of the space shuttle, and we're planning to test it today. We're very excited about that testing.
Famed for its reusability in the shuttle program, the solid rocket booster is now being further developed for use in the new Ares rocket system, which will eventually return man to the moon. It generates an incredible 15.4 million horsepower, equivalent to 32 jumbo jets at takeoff. But the source of that power makes it a potential powder keg.
It's absolutely the biggest firework in the world.
Firework rockets are powered by burning a solid fuel inside a cardboard tube. When this ignites, the jet of hot gas propels the rocket skyward. The principle behind the booster is exactly the same. The fuel is solid and made by combining powdered aluminium with ammonium perchlorate. The ammonium perchlorate acts as an oxidizer, supplying oxygen to the aluminium, which allows it to burn in the vacuum of space. Individually cast sections are joined together to form the finished booster. This controls and directs the blast of hot gas, which generates thrust and propels the rocket into the atmosphere. The advantage of this solid fuel design is that it's far less complex and volatile than liquid-fueled rockets. Even so, nothing in rocket science is that safe, as propellant disposal experts Jay Wimpy and Randy Oakson will testify.
This is a little bit of waste from the space shuttle production process. This small amount of propellant here looks like something that you could just toss over the fence and not worry about, but actually it could easily burn me and my partner to death.
Not wishing to miss out on the opportunity for a little pyrotechnic entertainment, we asked Jay and Randy to give us a little demonstration by igniting a kilo of the fuel.
Ready to fire in 3, 2, 1.
The propellant doesn't explode. Instead, the exposed surface burns at over 3,000 degrees Celsius. At this temperature, steel doesn't melt, it boils. And remember, in the main test, they'll be burning not 1, but 500,000 kilograms of this stuff. But while solid fuel rockets are far cheaper than liquid fuel designs, the downside is that once you turn them on, you can't turn them off. Which means the test team only get one chance to get everything right. With only 3 hours until the test, final preparations are made to protect the equipment. The biggest problem is ensuring that the booster doesn't take off and launch itself across the desert and into the mountains opposite. So it's fixed to an immense lump of half-buried concrete. This might not look like rocket science, but at least it works.
It actually contains 8,000 cubic yards of concrete, 700 tons of steel, and over 3,000 tons of asphalt that create a mass that resists the thrust of the rocket motor.
Let's hope so, because the local news media has turned up to watch, as has the local wildlife. But they need to keep a safe distance. If anything goes wrong, the rocket could blast a crater the size of a football stadium. At 1:30 p.m., with the Utah sun high in the sky, the engineers retreat to the safety of a bunker. Meanwhile, the news crews and spectators watch from what they hope is a suitably safe distance away. The last man brings the key to arm the rocket, and it's all systems go.
Roger, incident room 1, report system status.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 5.
With an earth-shattering roar, the booster explodes into life. Despite consuming over 5 tons of fuel a second, the booster casing is holding firm, as is the concrete block, resisting a force equivalent to over 7,000 express trains. After just 123 seconds, it's all over. It will take a while to analyze all the data from the test, but given that it didn't explode, it looked pretty good to us.
We would rate this test on a scale of 1 to 5, with 5 being high as a 5. A very successful test.
Thanks to the efforts of the rocket scientists at ATK, this high-tech firework is set to continue launching man into space for the foreseeable future. And with another successful booster test in the bag, NASA's dream of returning to the moon has moved one small step closer.